Right now, as you sit watching this, you are actually hurtling horizontally through space at over 1,000 miles an hour. You don't feel a thing because the speed is constant. Human biology is only wired to detect changes in acceleration, the jolt of a car braking, an elevator lurching upward, never the planet's steady velocity. Think of the Earth as a massive spaceship cruising at a steady pace. Now imagine what happens if that spaceship suddenly locks its brakes and comes to a dead stop for exactly 5 seconds. This globe shows the baseline of our world. At the equator, the surface of the Earth spins at roughly 1,000 miles per hour. That speed tapers off as you move toward the poles, but the total momentum involved is staggering. We live and build as if the ground beneath us is a fixed, immutable constant, never questioning the continuity of this rotation. In the first fraction of a second, the solid bedrock beneath your feet halts, 0 miles per hour. Newton's first law of motion now dictates every event that follows. An object in motion stays in motion unless acted upon by an outside force. The bedrock stopped, but you didn't. Everything unanchored retains its eastward momentum. Humans, vehicles, and loose Earth are instantly launched sideways, becoming supersonic projectiles. Near the poles, speed is lower, but at the equator and places like Ecuador, ejection hits 1,000 miles per hour. Even massive steel-reinforced buildings fail. The sudden discrepancy between the stationary foundation and the fast-moving upper floors shears skyscrapers in half right at the base. In these first 2 seconds, the very mass of our bodies and infrastructure has become a weapon, driven by a momentum the bedrock can no longer support. By second 3, the physics of the disaster shift from solid matter to the invisible gaseous layer surrounding the planet. The atmosphere lacks a rigid physical attachment to the crust. When the rock stops, the air continues rotating at its original speed. This creates global winds traveling eastward at 1,000 miles per hour at the surface level, where the moving air meets the stationary ground. For comparison, the strongest winds ever recorded on Earth were around 300 miles per hour. A 1,000-mile-per-hour gale acts like a continuous planet-wide atomic blast wave, stripping surface landscapes bare and tearing away natural rock formations. Surviving the initial inertial launch means nothing if the very air we breathe acts as a planetary sandblaster. While the atmosphere scours the surface, a different set of physical forces begins to act on the very shape of the planet. Constant rotation creates a physical distortion, a massive bulge of ocean water pushed outward at the equator. When the planet stops, the centrifugal force keeping this water pooled loses its anchor. Without it, billions of gallons rapidly migrate, flowing strictly toward the gravitational poles. Environments sheltered from the supersonic winds are now crushed by these migrating megatsunamis, proving that no region on the surface is safe. At the 5-second mark, the window expires. The Earth instantaneously resumes its natural spin. This sudden acceleration acts as a second, reversed kinetic shockwave, slamming the accelerating bedrock back into everything resting upon it. The crust plows into the still migrating oceans and the high-speed atmosphere, creating a violent physical collision of solid, liquid, and gas. The friction of this restart triggers global earthquakes as tectonic plates buckle and shatter under the sudden stress. When the dust and water finally settle, the global map is unrecognizable. The oceans have relocated to the poles, leaving a new, continuous landmass wrapping around the equator. This constant, high-speed rotation provides the physical equilibrium that keeps our oceans in place and our atmosphere breathable. Our planet's momentum is the invisible shield maintaining the world we take for granted every day.